Hi everyone. I'm sorry that I can't be in class today. My daughter is sick, and so is my son actually. Um, there's two videos that I'm making for you to help you understand what's going on with the lab. And what we're going to do in these two videos is first of all, we're going to look at how errors in measurement carry over when we make calculations with them. And then in the second video, we're going to talk about the information that our linear graph tells us about the lab setup. So basically the first video, I'm going to recap what you watched last time in video 82. And then the second video, we're going to talk about what's going on with the lab. So you still are going to have your labs due Friday, and you're still going to have a quiz on Friday, but you will be able to use notes. So that's the least that I can do since I won't be there. So the homework is to finish up the lab write-up and to watch videos 83 and 84. This is more of a suggestion just to watch those. I'll talk more about those in a moment. And if you have a lot of extra time, you can watch video 85, which is basically a proof of the ideal gas law. Okay, and so it is going to be a one-period quiz on Friday, and the rest of the time we'll talk about the physics photo contest. Okay, so first I want to talk about the two preflights. So here's the first one, and in this preflight, I just ask you to find the pressure exerted by 5 kilograms on a cylinder with a diameter of 6 centimeters. And all these different choices represent things that people do wrong, except for one. And so some of the things that people do wrong is that they forget to multiply by 9.8. So when we find the pressure, we remember that pressure is equal to force over area. So a lot of people forget the 9.8 is part of the force. Then the second thing that people do is that they use the diameter instead of the radius. So these are errors that people make. Okay, so you want to make sure that you're using the radius when you calculate the pressure, because that goes in for the area. And then the other thing is that the radius is not in meters, which causes the area to be not in meters squared. So we talked a little bit about this on Monday, but just make sure that your area is in square meters. Okay, so that was that first pre-flight. Now the second pre-flight is a little bit more complicated, and before I talk about that, let's take some time and review what was in the videos from last time. So there were basically two main concepts. The first was, okay, how do I talk about the different types of errors? Okay, and so the two different types of errors were absolute and relative, or percent. And if this is a repeat of what you already took notes on, that's okay. You can feel free to fast forward or just play it on 1.5 or 2 times speed. I just want to make sure that everyone's on the same page, and I'm sure that even though I told you to watch video 82, some of you didn't. So I'm just going to recap real quick. So absolute error we just defined as just the error in measurement. And this error in measurement usually comes from the inaccuracy of the measurement device. Okay, and we call that delta x. Or in our lab, we could talk about delta r, delta v, delta m, etc. This doesn't mean change, this means error. Okay, now these come from the inaccuracy of the measurement device, so you just have to estimate them. I would say that delta M is probably plus or minus maybe 1 gram for every kilogram. Okay, volume we said already might be 0.5 milliliters, but again, that's up to you to estimate how close you're able to read that volume. And delta R is plus or minus maybe 0.2 centimeters, something like that, maybe 0.05. Again, it depends on how good you think you're able to measure. And the other thing that I just want to point out is that I'm recording this video without a mic and a headset, so if the audio is a little off, you can just turn it down a little bit. Okay, so that's absolute error. Relative error or percent error is always compared to something. So for example, delta x over x is the relative error in x, or delta r over r, delta v over v, delta m over m. And this is a percentage because it's out of a certain value. Okay, so for example, if I said that my delta v was plus or minus 0.5 milliliters, but my volume was actually 50 milliliters, well, that's 0.01, which we would interpret as 1%. Okay, so the important thing about percent error is just recognizing that it's not all about absolute. You have to compare it to something. Okay, so if I had a delta x, an absolute of 0.001, that's really good. But if I was dividing it by an actual value of 0.002, well, that's really bad. That's 50%. Okay, but if I had 0.001 and I was dividing that by 1.56, well, that's going to be really small. So it all depends on what this ratio is when we talk about relative error. Okay, so now let's take a minute and, one more thing to talk about, and that's the two rules for combining error measurements. Okay, so first of all, when you multiply or divide excuse me, a measurement by a constant. So for example, in our lab, we said force was equal to mg, but m was actually mass plus or minus the error in mass. If that's multiplied by gravity, then you get mg plus or minus delta m times g. And then mg is the force, and delta m times g is the error in the force. Okay? Notice that these have the same relative errors. So if I do delta f over f, that's the same thing as delta m times g over over m times g, which means that delta m over m and delta f over f are basically the same percentage. Okay, so then the second rule is when you multiply or divide two or more measurements by each other. And so the example of this was z equals x times y, or z equals x over y. Okay, so the equation is delta z is equal to z times the square root of delta x over x squared plus delta y over y squared. And one way of thinking about this is that if I rewrote it as delta z over z equals the square root of all that stuff, this is a triangle where one side is delta x over x, the other side is delta y over y, and the hypotenuse is delta z over z. So the importance of this is just to say that if delta x over x or delta y over y is large, then delta z over z is also large. So if I have, for example, a very small delta y over y, So I did very good in measuring that. I have very low percent error, but delta x over x is large. Well, I still have a really large hypotenuse. Delta z over z is really big. So in other words, even if all of my other measurements are good, messing up one messes up everything. So that's kind of why we think about this, and especially for this lab, we want to think about which of our measurements are really messing things up. Okay, so let's quickly look at the preflight number 2. And in this one, this is also known as propagation of error, what I'm talking about here. Okay, and in this, what we wanted to do was to find the absolute and relative error in the pressure. So the first step is to find F plus or minus delta F, and we're using that first rule. And you can pause if I'm going a little fast. Then we need to find the area, which is pi r squared, or pi times r times r. So we use the rule delta z over z is square root of delta x over x squared plus delta y over y squared. And x and y are both r. And I'm actually ignoring pi because it would cancel out. If I did delta a over a, the pi would just cancel out. Okay, so this gives me delta a over a of 0.18, so that's 18%. Okay, so then if I want to get my absolute error, which is just delta a, then I multiply by the percentage. Now we do the same thing for pressure, so delta p over p is delta f over f squared plus delta a over a squared. And basically, this is going to come out to be pretty close to the same thing because delta f over f is pretty small. So this is a case where we're going to have, delta f over f is like the small leg, and delta a over a is the big leg. So the hypotenuse is almost the same as delta a over a. So that's kind of what's happening. Okay, so that's delta p over p is about the same as that. Okay. And that's what we're saying here, that it's mostly from delta a over a. So finally, we get our answer by multiplying the pressure by the percent error. Okay, so if you haven't already done this, what I'd like you to do is to pause or finish this video and go do this pre-flight to make sure that you understand this, because you're definitely going to see questions like this come up on the quiz on Friday. And even though I'm not here today, we are going to have that quiz, so make sure that you understand what's going on here. We might have a minute or two prior to the quiz for questions. Okay, so when you're done with this video, then you'll go on to the next one, and I'll talk about what happens in the lab.